finding our Okay, so when solving our trig equations, there's two ways we'll approach it. We'll do it the way in which we did it last year, and I think from memory, I can't remember if we looked at our general solution formula, which is also another way we can approach it. So look, we'll do the general solution straight after this. We might change the order of things, and then you can pick whichever method you prefer. All right, so the key process is you first of all got to determine the angle that we're dealing with. Okay, it doesn't matter what sign it is. So if we're doing it tech-free, we're only going to be working with angles of 30, 45, 60, those sorts of angles. So you have to know the exact values. So once you've got the angle that we're dealing with, you've got to then go to the two quadrants where our function is either positive or negative. And that's when we take into account whether we're solving for negative a half or positive root 3 on 2. Then we get those two solutions between 0 and 2 pi using our symmetry properties, and then we add and subtract. Okay, you can either do it add and subtracting the period or add and subtracting 2 pi to work out all your answers. All right, so let's have a look at a couple and see how we go, remembering from last year. So first step is to rearrange our equation. Oops, get the right pen. Rearrange our equation so that we solve for cos. So cos theta is equal to, that would be the same as negative 1 on root 2. Okay, so if you like, our first step is, so work out the angle. Theta is equal to cos inverse of, don't worry about the sign, 1 on root 2, working in radians, so it's pi on 4. So then we make a decision, okay, whereabouts is cosine negative? Well, cos is negative there, and the angle that we're dealing with is pi on 4. Then, okay, we're starting at the domain, which is from negative pi to pi. So let's just work from 0. We'll work from 0 and go two ways. So my solutions will be theta will be equal to, start at 0. This angle there is pi minus pi on 4. The next angle, if that's pi as well, pi plus pi on 4. So that gives me 3 pi on 4 and 5 pi on 4. So now all my other solutions are going to be plus or minus 2 pi from that point there. Okay? So if I add 2 pi, I would also get, well, 2 pi is the same as 8 on 4. So I get 11 pi on 4, 5 plus 8 is 13 pi on 4. Add another 2 pi, 11 plus 8 is 19 pi on 4, 13 plus 8. Now, I obviously don't need all of these, but that's how I could find all my solutions. If I want to get the negative ones, I subtract 8 pi on 4. So I would also get 3 pi minus 8, which is negative 5 pi on 4, 5 pi minus 8, which is negative 3 pi on 4, subtract 8 again, negative 13 pi on 4, subtract 8, negative 11 pi on 4. So I could keep doing that. And then my final solution are the ones that are within that domain. So with more practice, you realize how far forward or how far back you need to go. So if we concentrate on the ones that fit, 3 pi on 4 obviously is within. And there should be a negative one here somewhere. Negative 3 pi on 4 fit. Negative 5 pi on 4 is too big. 5 pi on 4 is too big, or outside, I should say. So my final solution's theta, negative 3 pi on 4 and 3 pi on 4. Okay? So we'll do it again, but this time around we won't put all those extra solutions. So again, step 1, get the function on its own, negative root 3. So what angle gives me root 3 for tan? That's the last one, so that's pi on 3. Okay, we're working in radians. Whereabouts is tan negative? Well, tan is negative. Where is tan negative? It's negative there. Whoops, it's positive there. So let's get rid of that. if we have to, put a little ASTC. So tan is negative there and there. So the angles that we're interested in are from there and there. We're working from negative 4 pi to 0. So let's start at 0 and work backwards. So the first angle is, so that way theta is equal to negative pi on 3. And that's negative pi minus pi minus pi on 3. So that gives me negative pi on 3 minus 4 pi on 3. And now I'm just going to continue to subtract 2 pi, which is 6 pi on 3. Okay, so the rest of my answers, negative 1 minus 6 is negative 7 pi on 3, negative 4 minus 6, negative 10 pi on 3, take off another 6, negative 13 pi on 3, take off another 6, negative 16 pi on 3. And that's where we can stop, can't we? Quick check between negative 4 pi and 0, which is why we didn't go to the positive solution, up to negative 4, so 12. Well, we can stop here, can't we? So negative 4 pi, so neither one of those fit. So these are my 4 solutions. Okay. Now the last one is we have sine x equal to cos x. So whenever we have sine and cos, remember that tan is sine over cos. So if I divide both sides by cos x, I get divide by cos x, I get tan 3x is equal to 1. All right, so tan of what angle is equal to 1? That's 45 degrees, so it's pi on 4. So don't forget, tan inverse of 1 equals pi on 4. So the difference, slightly difference here, we've got 3x. So here we can say 3x is equal to all my solutions. So let's do my little, whereabouts is tan positive? It's there and there. Pi on 4, pi on 4. So my first 2 solutions are pi on 4, and that's pi plus 5 pi on 4. And so I guess there's 2 things I do. Because we've got a 3 here, I go around 3 times the domain. Okay, so if I add 2 pi, which is 8 on 4, to all my answers, I'm going to get 9 pi on 4, 13 pi on 4, another 8, 17 pi on 4, 21 pi on 4. Now, clearly they're far too big for 0 to 2 pi, but we're going to divide everything by 3 here in a minute. So let's just do one more just to make sure. So if I add another 8, I get 25 pi on 4 and 29 pi on 4. Now I'm going to divide everything by 3. So if I divide by 3, it means my denominator increases. So I get pi on 12, 5 pi on 12, 9 pi on 12, which I could simplify, 13 pi on 12, 17 pi on 12, 21 pi on 12. Now at here, this is where I should see 25 on 12 is too big because it's bigger than 2, so I don't have to worry about the last 2 solutions. So my x value in this case is all of these. Okay, look, maybe we could simplify them, so that's 3/4, isn't it? 3 pi on 4, and over here we've got 7 pi on 4. Whoop, 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 whoop. 7 pi on 4. Okay, so look, lots of practice, lots of practice. We can't get anywhere, even if you have to do a little table when you first do some triangles. You know, if you have to go 60, 30, 2, 1, root 3, just, yeah, do something that you've got those exact values in front of you. Okay, practice those.